Hello everyone and welcome to Frogs, Fleas, and Painted Cubes 3.4. This investigation begins on page 52 of your textbook. Our learning target today is we'll be able to correctly find patterns in quadratic relationships with the first and second differences. Our ACES questions for 3.4 are 20 through 25 and 27 through 30. Now you might be asking me, what are first and second differences? Well, that's a great question. Let's dive into it. So here we're looking at a table of information. It gives us the equation of y equals 3x plus 1, and then we have our table with x values from 0 through 5, and we plug each of those in for x, and that gives us the resulting value for y. Well, we should remember from thinking with mathematical models that looking at an equation like this, that it is linear. In order for that to be, then our unit rate of change here has to be the same for each value of x with our resulting value of y. And we call these first differences. So the difference between 4 and 1 here is 3. The difference between 7 and 4, 7 minus 4 is 3. 10 minus 7 is 3, so on and so forth. And because the y value increases by 3 each time as the x value increases by 1, the first difference for y equals 3x plus 1. And they're all a constant amount of 3, and again, that gives us a linear function. Let's take a look at some other equations, shall we? Well, first we want to take a look at what the equation is. It's y equals x squared, and we again have our values of x from 0 through 5. If we plug those in here, we get differing values for y, and our first differences, 1 to 0, 1 minus 0 is 1, 4 minus 1 is 3, 9 minus 4 is 5, so on and so forth. Well, as we look, these first differences are all different. We don't have the same unit rate of change that we had in our previous equation. But if we look at our second differences, meaning the difference between the differences, we will see that these are consistent. 3 minus 1 is 2, 5 minus the 3 is 2, 7 minus the 5 is 2, and 9 minus 7 is 2. These are all the same second differences. When you have a situation where you have all of the same second differences, you then have a quadratic equation. So what we're going to do here is mess around with that a little bit in our problem. If you look on the back of your rubric here that I've given you, on the second page on the back of it, I have provided you the tables and alignments for first and second differences for all of the problem 3.4 so that you don't have to make them up all on your own. It gives us 4 different equations to be able to fill the tables out on, and again, I've already put that out there for you. You can see that these equations match up here, and if I go to the next page, these equations match up here. After you've filled out the tables, the first differences, the second differences for each of these, they want you to consider the patterns of change in the values of y in the first and second. In what ways are they similar? What ways are they different? And then would these patterns of change be right for a quadratic function? Then for part B, again, we're given 4 different types of equations. This is on the back of your rubric as well. Fill out the tables with each of the 4 different equations for the table, first differences, second differences. Again, then we're going to look at all 4 of these and determine how they're similar and how they're different, and with these patterns of change, what type of function does that lend us to believe it's going to be? So experimenting with those. And then finally in C, it asks us if the second differences are the same for all quadratic equations. And so you can experiment with that. You might plug it into the graphing calculator. It's entirely up to you how you go about trying to find out if the second differences are the same for all quadratic equations. That's it for 3.4. Again, our ACEs are 20 through 25 and 27 through 30. Look forward to your questions and comments in the classroom.